Volume of a cuboid. So first let us understand that what is volume. So volume is a space consumed by a particular object. Now let us suppose that we have a cuboid and we fill a lot of water in it. That is, we fill the whole of it with the water. So the amount of water that can be filled in that whole of the cuboid is called as the volume. So similarly, in order to find out the volume of any other object, we'll see that how much amount of water can be filled in that object, and that amount can be termed as the volume of that object. And similarly, we can fill the water in any like cone, cylinder, and etc. So if not water, even the amount of air that can be filled in that object can be termed as the volume of that object. So here the volume of the cuboid will be the amount of water that can be stored. So we have a rectangle and we stack this rectangle over one another. So now it has three dimensions, that is length, breadth and height, and this is how a cuboid is formed. So this cuboid will have a certain volume, that is the amount of water that can be filled. So it has a length, breadth and height. So let us suppose that we increase the length of the cuboid or the breadth of the cuboid. When we increase either of them, what we are doing is we are increasing the base area. That is, we are increasing the surface base area of that cuboid. When we do that, we will be able to fill more amount of water in that object. So the volume will increase in that case. Now similarly, a cuboid also has a height to it. So when also we increase the height of the cuboid, then also the volume of the cuboid will increase. That is, more amount of water could be filled. So therefore, intuitively, what we can conclude is that the volume of the cuboid or the water that can be filled in this whole object is equal to the area of plane region by rectangle into height. So intuitively we can say that. So this is what the volume occupied will depend on. So the volume occupied will be area of the plane region by rectangle into height. So the area is equal to length into breadth of the rectangle and height is the h. So the volume is L into B into h. That is the volume of the cuboid. So we can conclude that volume of cuboid is length into breadth into height. Let us now calculate the volume of the cube. So cube is basically nothing but a cuboid with equal dimensions, that is length, breadth and height are of same equal value. So in order to calculate the volume of the cube, we will be using the same method. So the volume of the cube will be equal to A into A into A, that is LBH, and this is equal to the A cube. So what do we see is, we can conclude that the volume of the cube so found is h into h into h, and the value of h is A. Let us do an example in order to understand the concept. So the example is, a solid cube of side 12 centimeters is cut into 8 cubes of equal volume. What will be the side of the new cube? So we have a solid cube that is being cut into 8 cubes. So the side of the solid cube is 12 centimeters. So we can calculate the volume of that big solid cube, and we have the side as well. Volume of bigger, that is the big solid cube, will be equal to side cube, that is h cube. So the h is equal to 12, so 12 cube, and this is equal to 1728 centimeter cube. Now since this whole cube is being divided into 8 cubes of equal volumes, so we can divide this amount of volume into 8 parts. So when we do that, we get the volume of one little cube. So 1728, that is equal to 8 times the volume of the smaller cube, that is we have cut. So we can calculate the volume of the smaller cube as is equal to 1728 divided by 8, and this is equal to 216 centimeters cube. This is the volume of the one little cube. Now we can calculate the side of that little cube. So side cube is equal to 216. So therefore the side of that cube will be cube root of 216, and that is equal to 6 centimeters. So we have the side of the new cube as 6 centimeters.